Hello, everyone. I'm very happy to have today John Jensen from USA. SMC, as you know, it is the largest corporation in pneumatic industry. Hi, John. Nice to meet you. How are you today?
Oh, I'm great. Thanks. It's nice to see you today. Thank you for having me join you.
John, can you just tell us to our listeners and also viewers of our interview about your position and what you do? So I know that you are responsible for energy efficiency, but I guess it's not just the US.
That's right. I manage the energy efficiency team in the US, which covers all of North America. And I also have some responsibility for the global energy efficiency teams. I work directly with the coordinator in Europe and another in Japan. And then we also have teams in most of the countries where SMC does business.
Okay, great. So can you just tell us a little bit about, in general, about the energy efficiency and energy consumption of pneumatics and why it is so important for SMC? I'll tell you, explain you also my question, that I think that compressed air and pneumatic system were developed not to be like so efficient when the technology was just like developed. So we were not thinking about the energy consumption at all. And when we look at the standards or when we look like at the practices that were adopted, so we didn't think about it. But now we started to think about the energy consumption. And you are the largest manufacturer in the world. What is actually about the energy consumption and energy efficient pneumatics?
Well, it's true that the systems we inherited were not necessarily designed for great efficiency, and even some of the old textbooks and the old best practices allowed for fairly significant pressure drops in newly designed systems, and we're starting to look at that now, and even in a matter of not only the sizing of the distribution systems and the piping, but even actuators. And when machines were designed, there wasn't necessarily a lot of thought giving to the size of the actuator. If you had a larger one on hand, you just used it, right? Whether it was necessary for the application or not. So I think
Yes.
the processes or practices we inherited didn't do us any favors, even to something as simple as, does the machine pressure turn off when the machine is idle, right? We didn't design that in basically that's not been a criteria for machines. It's starting to be now, but we have machines even not more than 4 or 5 years old that remain fully pressurized even when they are sitting idle for minutes or hours or days or weeks. So
Yeah.
some of those best practices, the best practices we had are out of date, and I think the trend is to start now looking towards efficiency and total cost of ownership or operating cost as we design new machines. And we're also starting to see, we're doing a lot of consulting on what's possible to bring older machines at least a little further along in their efficiency.
So also for the older machine, it means that there are some retrofit programs, or how in general it works? Like you analyze it first and then you propose energy saving measures, or what is the procedure?
We do a couple of things. Certainly specific things that we can improve, like airflow for cooling or for moving parts or for parts feeding and those kinds of airflow applications. We always look to improve those. But on the machine in general, there are retrofit kits that can replace the standard filter regulator or air preparation assembly with a new model that has additional monitoring and that has onboard capability to remove or reduce the pressure when the machine is not in production mode. And that is able to be added to a machine typically without modifying the machine's programming, because nobody wants to touch an old PLC, right? No one wants to change the code for fear of causing the machine to break down. So these retrofit kits are meant to be fairly easy to implement without jeopardizing production.
Okay, and what about also the components themselves? Because I know that in SMC you have some more efficient components like cylinders of intermediate sizes. So do you also retrofit, like modify the hardware of the machine, or it's only on the pressure level reductions or things?
We have done modifications of the hardware, going back to look at an existing machine and reduce actuator sizes where possible, reduce tubing sizes where possible. But that takes a fairly strong commitment from the client to be willing to do that. So that isn't always doesn't always have a significant return on investment. There's significant time involved in and downtime for the machine to do some of those very detailed retrofits where it includes a cylinder of a non-standard bore size or replacing all the tubing. We have done, but it's sometimes it's not. The payback is too long, and that might not be feasible. Something that detailed is probably easier to write into the specification for a new machine than it is to bring an older machine up to speed. But the simpler things to do, like controlling when pressure is on or off or reduced, that's easier to implement on an existing machine than it would be to look at every actuator and resize it to the correct size for the application. So it kind of depends. It would be like if you wanted to take a 40-year-old car and add all the safety features that a new car has, it would be more cost effective to buy a new car.
No, that's interesting. So basically, I mean, you are very experienced in the various energy saving measures. I wanted to ask you more not on the technical side, but more on the customer reactions, because sometimes, like when you talk to customer, for them it might sound very difficult, or like the ROI has to be 2 weeks payback. I'm joking, of course, but what is usually like the points that customer are more sensible to any modifications or to any energy saving measures on their production line?
Yeah, well, fortunately, many of the suggestions we can make, like improving an air blow or changing a nozzle to a more efficient model, or pulsing the air, or equipping the machine with an automatic shutoff, those are fairly short return on investments in many cases, where it's in less than a year. So those smaller projects are usually adopted. And now, of course, implementing those projects for our customers is also challenging, because usually they expect the maintenance department to simply absorb those extra duties, and so it's not always something that happens quickly. It really kind of depends on the client and how invested they are in making that happen. It's more successful when, especially for a larger customer, where their corporate office has budget to allocate to an individual facility to make improvements on energy efficiency. If it's just expected to be done as part of the annual maintenance budget, it's a little harder to get some traction on those kinds of projects.
Yeah, so it's more like on the strategic view. And what is the guidelines for the new machines? So after you analyze the old one, you also can give guidelines for for new lines, right?
Yes, absolutely. So some of the new thinking is that the machine should be automatic, should come with monitoring for pressure, flow, temperature, perhaps dew point, or other key variables, and that monitoring system should also have the ability to reduce the pressure when the machine is idle for a short period of time, and remove the pressure when the machine stops. So those are the biggest savings, that we don't have machines sitting idle and consuming air. Those are significant savings. It's the same analogy like to an automobile. When you are driving your car on the highway, you are applying power. When you're coasting, the engine goes to idle, and when you come to a stop sign, it turns off, right? And we are starting to expect that a new machine would be equipped with the same kind of technology, that it would go to an idle mode and then go to an off mode as frequently as it can. I mean, and I know that savings is incremental. It's a few pennies every time, but it adds up over the course of a year, or over the life of the machine. So that putting that in the specification, writing specifications to that cylinder bores and strokes should be exactly what is needed for the application, rather than simply a couple of sizes larger. Those are some of the things that customers are starting to write into their design specifications for new machines.
Yes, no, yeah, I think it's very important. And basically, do you work mostly then with the end users or more with the machine builders? Because the consumption, this is usually like, the question is like, machine builder does not pay for the energy consumption, but this is the end user, but the machine builder is responsible for the consumption. And sometimes we see that we don't even have the data, required data for this.
No, that's very true. We start with the end user because they would have to drive the specification or change the specification. So we start there, and it's true many times the capital equipment buyer has been given no instruction to consider the operating cost. That's another department, right? So a person buying or ordering machinery is very often just tasked with getting the lowest price for the machine that meets the needs. And so what we try to do is to encourage those three-way conversations, or even between the capital equipment purchaser, the operating manager, or the person in charge of facilities or operating costs, and the OEM, the original equipment manufacturer, that if we can get all of those people around the table to talk about operating costs, because the machine builder doesn't have an incentive to build efficiency on their own, right? Because that if that increases their cost at all, they're afraid to lose a bid or to reduce their profit margin. So unless the end user specifies, nothing happens. So trying to connect the dots or connect the departments is part of what our strategy is to make sure that everyone that should be at the table when equipment is being purchased or designed or requested, that they all should be around the table. And even within the customer's organization, you all should talk, right? It's kind of the instruction or the method that we go down.
No, that's very important. I also experienced it myself. Like, what is do you think this is like the biggest challenge in our industry in terms of the energy efficiency, or there are some others? So what is, in your opinion, the biggest challenge?
I think that's the biggest challenge, and I'm starting to see some improvement in that we have some success where clients are starting to see the benefits of designing this in, and also going back to retrofit, and I think we're seeing, not just for energy savings, but we're seeing a trend in manufacturing that monitoring and big data is becoming important. So that I think people are coming around to the fact that if we're not measuring it, it's very, very hard to improve it. And that has been difficult to encourage, because spending money on monitoring doesn't directly save you any dollars, but it gives you the information you need to make an improvement. So that's slowly changing. I think that's the next trend. We're starting to see monitoring at the system level, and of course the one of the main things that SMC is proposing is monitoring at the machine level.
Yes.
And
So it is more like on
the
so it's more on the before the production line of machine, or it's also somehow connected with other components that are inside the system, inside the machine.
Right. It would be the simplest would be right at the machine's air pressure inlet, but of course machines have multiple sensors inside already, and if we can make it very easy to extract that data or access that data, then you can start to get enough information to not only and I think this is probably where we're going in the future, not only monitoring for efficiency, but monitoring to prevent a breakdown or to prevent an unexpected stoppage. Because if you have the information, for example, if you know the machine's motion profile and you can map that against the pressure and flow profiles, when you see an anomaly, if you see a spike or an increase in flow at a particular point in the machine's cycle, you can narrow that down to say that, well, there must be a leak on cylinder number 3, for example, because 10 seconds into the cycle, the flow is supposed to be 30 liters per minute, and now it's 50. What's happening there? Well, that cylinder is retracting. Well, chances are then it's the rod seal on the cylinder, or perhaps the tubing or the fitting. But you have now reduced your troubleshooting time by having the information to know not only that the machine is starting to leak, but where that problem is, right? So
I think the Of the leak is one of the biggest issues and challenges in general now for the machine. So
Yes.
it's not only about the compressed air cost, but it's actually about how much the downtime of the machine cost, right? So this is the higher cost.
And that's usually a larger number, right? A downtime for an hour may be a significantly greater cost than the amount of compressed air used in an hour. So I think, I think these two are complementary, right? That we are reducing leaks for energy savings, but most pneumatic failures are predicted by leakage rate, or can be. As the component starts to wear and starts to leak, you can start to see that a failure will happen at some time in the future. Of course, the reason we like pneumatic components is they can leak badly and still work. So we like that they're very robust, but that's encouraging bad habits of not repairing things when when the leak rate gets to be a critical point.
That's great. You know that talking about the components that are robust, a lot of people talk about the electrification and replacing in the future pneumatic drives by electric drives. What is your opinion on that?
Oh, I think it's very application specific. I think there are definitely places where electric drives and electric actuators are the better choice, but it does typically, and that gap is lessening. It used to be that the electric actuators were considerably higher cost, maybe a factor of 10 or even 20, and that gap is reducing, of course. That electric actuators are getting within a smaller margin of price increase, but it's also, as I said, very application specific. If an electric actuator is needing to hold position, that causes it to consume power. But with a pneumatic actuator, if I'm holding position under pressure, but there's no airflow, then I'm not consuming any additional power. So it does depend on the application, right? It's continuous, so there are cases where, certainly there are cases where the electric actuator is more efficient. But it may be that the return on investment due to a higher initial cost may eradicate some of that benefit. But there are also cases where pneumatic actuators are more efficient even in the long run. So there's no good way to make a blanket statement on that, other than to say that the number of electric drives and electric actuators is increasing, and certainly most manufacturers of pneumatic components are offering electric equivalents in a lot of cases, even to simple actuators which don't have any speed or motion control, just simply extend and retract, for example. Fairly inexpensive electric versions of the pneumatic ones are being considered. I think we're seeing them more used in machines that wouldn't, or where having access to compressed air is inconvenient, like in medical facilities and things like that, where compressed air infrastructure doesn't exist. We're starting to see more, or in very small facilities or independent operations where a purchase of a compressor would be necessary unless the actuators could be electric. So I think we're starting to see that trend happening for sure. I think it'll be slow, but we're seeing it.
And talking about trends in general, how you see the applications of compressed air and pneumatics industry in the future? Is it going to decrease? Is it going to be like more digitalized? I mean, we're all going into IoT, but still, like, what do you think it's the future?
I think there are still quite a few factors that make, even though it's not a very efficient, that make using compressed air, using pneumatic systems, I think that's still going to be attractive for, even though it's not very efficient, total cost of ownership still, because of the upfront cost, the long service life, the ability to make pneumatic components very robust, especially for adverse environments, right? It's much easier to make a pneumatic actuator to tolerate a chemical wash down in a food plant than it is to make an electric drive or electric actuator tolerate a high pressure wash down or chemical. So those kinds of things, especially in difficult environments, I think we're going to see pneumatics still with an advantage. But I do think we're moving in the direction of electric drives will be used where they can, simply because of the operating cost. But there, wherever that point lies in the scale as to where, when it makes sense to invest a little more upfront for a lower running cost. I mean, that again is very, very machine specific or application specific.
Yeah. Okay. And maybe like as the last question, like what would be like your wish if you could do all the pneumatic system efficient? Is it like that the customers would more listen to you, or maybe you wish like for a new standard or any like a policy or any initiative or something that you think would make our work really easier?
Well, that would be interesting. To have it legislated as a standard or policy, that would be interesting. I don't know. Uh, there's some small movement in that direction. For example, but we're starting to see it more on the supply side or the system side. So, for example, the state of California has in their building codes for commercial buildings that compressed air systems over 100 horsepower, over 100 kilowatts, or uh, additions to a system more than 100 kW require that the system be leak tested during commissioning and that there be monitoring. And that's just one state. So they're legislating at least a couple of good practices that we should monitor the flow, and we should, when we commission the
That's really
system,
great.
we should
Yes.
we should check it for leaks, right?
Yeah.
So we're starting to see that a little bit, that compressed air, in the past has never even been mentioned in building codes or standards, right? It's not part of the process, but we're starting to see that now. Just a very, very, very incremental amount. So I think though that it will come down. I think looking at efficiency in compressed air will come down to necessity for budget. There are cost savings to be had in using more efficient machines, and I think many of our larger clients have published their sustainability goals. Right, they're planning to be carbon neutral or to reduce their carbon footprint by a certain percentage, and compressed air is a good target for that. It's
Yes.
not difficult to make some significant improvements, as you know, right? Improving even a small air blow application can reduce your CO2 emissions by several tons or by many tons per year. So I think part, especially the larger customers, the Fortune 100 clients, are starting to see that this is a target area for improvement to help them meet their sustainable development goals. And
Yeah.
not only in operating cost, but they're starting to look at, there's a trend towards looking at components that are designed to use a small amount of raw materials in their production, using components that their own carbon footprint is small. So that trend, I think we're starting to see that being pushed back to the second and third tier suppliers, right?
Yes.
And customers are asking us, why this particular actuator, why should I use this one? Well, it uses 40% less raw material than the previous version, right? So
Yes.
that even the whole supply chain, I think that will start to drive improvements for us when people start
Yeah.
looking at their whole supply chain for pneumatic components, that they're help meeting their goals by taking a look at that as well.
That's great. I think that's a great point. And the standards, like also like eco design and new ISO standards, I think they really also help customers to be aware of this, so they can see the full supply chain. Well, we'll hope that we can fast forward this
Oh,
energy
very good.
efficiency measures. Great, John. Thank you so much for your time.
Oh, you're very, very welcome. It was a pleasure to visit with you today, and I hope
Yes,
we can speak again.
yes, pleasure for me. Thank you.